So 11.6, we will deal with the odd and expectation or expected value. And then 10.7, we will deal with the additional rule for probability. So we will step away from the combination and permutation material. We will kind of jump into probability with a different set of rules for probability. So let's take a look at the odd first. So for us, or for this author, for this book, this is how he defined for you to find the odd. So if an event have a favor odd, which is we call it A, some number in favor of the item we have, and the B is the unfavorable outcome, meaning again, in the way to think about this thing here, you will hear me say a lot that A is what you have and B is what you don't have, right? So basically the odd in favor, so they will ask you for two items, is they ask you one, find the odd in favor of the event, and B, they will ask you find the odd against the event. Okay, so basically all you need to do is find the odd in favor of the event, is basically find what you have, which is the A, the item you have, over B, the item that is you don't have. Okay, so again, one thing is the odd is different from probability, ladies and gentlemen. If you remember, probability, I told you, is what you're looking for over the total. What you're looking for over total, that's the probability. But now the odd is basically what you're looking for over the thing that you're not looking for. Okay, whatever you try to find over the leftover that is not. So it's not over the total. Okay, it's basically something against the other item. So let's take a look at the example here. And let's say A, you are rolling a 6-sided dice. Find the odd in favor of rolling a number 2 or number 3, right? So again, we know that this dice, we have a 6-sided dice. And to roll this number 3, do you agree that there are one side contain a number 3, which is that's what you have. We have one side contain 3 dots. And now, how many side that does not contain the 3 dots that we're looking for? Do you agree that the leftover is the 5 other side? The side contain 1 dot, the side contain 2 dots, the side contain 4, the side contain 5 dots, and the side contain 6 dots. So in terms of this thing here, what we're looking for the side contain 3 dots, which is we have one side over the side that contain anything other than the 3 dots, which is 5. So the odd in favor, if you have a dice, if the odd in favor is basically 1/5, or the ratio of 1:5, meaning there are one side contain 3 dots to the 5 side that contain not the 3 dots. Okay, so again, that's all there is for this odd. To find the odd is what we're looking for, or how many items we have over the item that we don't have. Okay, again, in the sense of the other way, in the sense of the other way, it's just the reciprocal of the odd in favor. If they say you are rolling a single dice, 6-sided dice, find the odd against rolling a number less than 3. Reminder, what does it mean less than 3? Is 3 less than 3? Okay, that's what you need to ask yourself. Is 3 less than 3? Hopefully you say that 3 is not less than 3, right? So what is the item that considered less than 3? There are 2 items in terms of the number 1, or the 1 dot and the 2 dot, right? Those are the item that is less than 3. That is the item that we have. And the item that is not less than 3 is the 3, the 4, the 5, the 6, right? So the odd in favor, if they ask you the odd in favor, is will be 2/4. But in this case, they change the script and they say odd against. The odd against, you have to put them in terms of 4/3. I mean 2. 4/2, which is odd against rolling a number less than 3, which is 4/2. And 4/2 you reduce to 2/1, or in the sense that 2 ratio of 2 to 1. Okay, you have to write, because of the odd, you have to write 2/1. I know it's basically because of the odd, is basically tell you that there are two items against the one item you have. Okay, so the odd in favor is what we're looking for over the item we are not looking for, and the odd against is what we don't have or what we're not looking for over the item we're looking for. Again, ask yourself, what are we looking for? How many items fit the description that we're looking for over the item we're not looking for it, right? And I believe on Alex, they give you, they give you like the camera, the DVD player, and something like something else, and they say, what is the art of winning the DVD player or something like that. And again, we will look at those questions later on Thursday, but the idea is the same, is what fit the description over the item that doesn't fit the description on the leftover item. Okay, it's not the total. And the difference between the odd versus the probability is, the odd is we put the value into our item. 1 to 5, the 1 to 5 odd is basically we try to put the value in our probability, in the sense that for 1 to 5 is basically, if you bet $1, you will win $5, right? So as you can see, the odd is good, right? You say, oh, if I lose $1, but if I win $5. It's a good odd. But the probability is very bad, right? You have, what are your chance of winning? Well, your chance of winning is if you roll the dice, right? And if it's land on the 3 dot, you win. If it doesn't land on the 3 dot, you lose. Meaning the probability is 1 out of 6, right? But again, the odd is basically you have 1 against 5 other side, right? So that's what the odd is we try to put the value into our probability. Okay, so once we can find, now if we have the item, we can find the odd in favor and odd against. Now the other way around is, what if they give you the odd in favor and they ask you to convert back to the probability? So if if they give you the odd in favor and ask you to convert back to the probability, so if you remember last time, or if you remember, I mentioned this, right? If you remember the odd in favor, the previous problem, the odd in favor of rolling a 3 is 1 to 5. So the odd in favor of you rolling a 3 is 1 to 5, meaning this one right here, this is my A item, right? How many sides contain number 3? And this 5 right here is my B item. This is what they tell you, that if they give you the odd in favor, and this is only odd in favor, ladies and gentlemen, if they give you the odd against something, you have to manipulate them around. But if they give you the odd in favor, then you can convert that odd in favor to the probability. How do we do that? So whatever odd in favor they give you is always A to B. If it's odd in favor, it's A to B. So if they give you A to B, to find the probability, as you can see, find the probability of rolling a number 3. Everybody see that this right here, the probability of rolling number 3 is A over A divided by A plus B. So what does that mean? Well, that means you have 1 over 1 plus 5. And what is 1 over 1 plus 5? Well, 1 over 1 plus 5, do you agree that 1 divided by 6? So the probability of you rolling a dice is, again, how many sides contain number 3? We have 1 side. What is the total side we have? The total side we have is, we have 6 sides, right? So that's the difference between the probability versus the odd. The probability is the chances of something occur. The odd is the value we put it into that item. Okay, but to be in short, to find a probability, if they give you the odd in favor to find the probability, all you need to do is take the A, put it over the A plus B. right? So you will see something like this, right? According to the National Safety Counselor, the odds of dying due to the injury at some point in your lifetime are 10 to 236. Very negative example, but it's the example from the books, right? So this is what the odds is. The odds is 10 to 230 237, or 1 to 223.7, right? So looking at this thing here, they ask you, if this is the odds, what is the probability of die from injury, right? Let's say whatever injury that occurs based on whatever the survey is. So what is the probability? Well, the odds in favor, that's the first thing you ask yourself is, do they give us the odds in favor? And this thing here, they give you the odds in favor of dying, okay? Unless they say odds against something. But mostly is they give you the odds in favor. So this is the odds in favor, which is the 10 is your A, and the B is the 237. Find the probability of dying from injury. Well, to find this probability, everybody see that my A is 10 and my B is 237. In this case, all I need to do is put 10 over 10 plus 237, which 10 divided by 240. As you can see, is not really, this thing here is rarely, it's not even 5%. It's only 4% to be exact, right? So 4% of dying from injury. So it's a negative example, but come out to be not that big of a negative, right? Whatever injury based on this safety counselor is only 4% of dying if you have some sort of injury. Okay, so there's 95 or 96% of living, right? If you looking at that. So looking at this thing here, this is what they ask you to do is, if we were to give you some problem, can you convert to an odd? Or vice versa, if we give you an odd in favor of something, can you find me the probability? So in the sense, it's just basically this formula that you have to figure out in terms of A over B, or odd against is B over A, and vice versa. If they give you A over B, to find the probability is A over A plus B. Okay, so and again, if they were to tell you, and most of you, let's say if you watching, if you read in the if you horse racing, right? Most of them, you have horse racing, and they say the odds in favor, the odds is 2 to 7. Let's say the odds for the horse is 2 to 7, meaning you in this case, if the odds in favor of winning is 2 to 7, what will be the probability? Well, the probability, if the odds is 2 to 7, the probability, as you can see, the probability of winning will be 2 divided by 2 plus 7. And this thing will give me 2 over 9. And that's all they tell you is, if they give you the odds in favor of something, all you do is take the first item divided by the addition of the 2. Okay, so that's how you find, if they give you the odds to find the probability, that's what you need to do. Okay, so question here in terms of how to find the odds, or how to find the probability if they give you the odds. Now, the last thing in 10.6 is probably the hardest, the most difficult item you will see, which in terms of the expected value or expectation. So the expected value is just basically tell you that in a long run, in a long process, what should we expect out of the item that we're doing, right? So basically, if we keep on flip the coin, right? If we keep on flip the coin in the long run, we should expect that it's 50% head, 50% tail, right? 50-50, right? So basically, that's the idea is, if we have some sequence, if we have some pattern, what will be the expected, what will be the expectation, right? If we know the outcome of, we know the probability, what should we expect out of the problem? Okay, so this is what I tell my student. To find the expected value, the easiest way to do is construct this table. So you want to construct this table with 3 columns. So the 3 columns you want to construct is the first column, you want to put in the amount of your item. And most or all of your expected value, you will have some amount gain, which is your profit, and the amount of loss, which is your loss. And the amount of loss, we put a negative number to illustrate that we are losing something. And the profit, we put a positive because we gain it, okay? So that's the first column, is you identify the gain amount, which is positive, and the loss amount, which is negative. And you most likely will have both of them. You will have some winning, you will have some losing. The second column is you need to know what is the probability of gaining, what is the probability of losing. So basically you have to find the probability of a given item. And the third column, you need to multiply the first column with the second column, meaning you need to take the amount multiplied to the probability. Okay, so again, construct the table, find the amount, find the probability, and multiply the 2 items together. And to find the expectation, all they tell you to do is add them together. If they are positive, you add them. If they are negative, you subtract them. Okay, so let's take a look at this in action. So let's say that this is your story. If whoever go casino, you probably saw this. Find the expected value of better than $1 on the number 20 in the roulette table. So if you go into a casino, if whoever go casino, this is your roulette table right here. The roulette table is this thing here. The dealer spin the ball, right? And it's land on, and you bet $1 on number 20. So this is what you want. You want the ball to land on, this particular number 20. That's what we want, right? The ball spinning, land on here. So if the ball land on number 20, you will win. You will award $35, meaning that is your profit. You will win 35, and you will cap the $1 that you bet. That's your original dollar. So your profit here is not 36, but your profit is only 35. Okay, so they tell you that you get $36. It's not you winning $36, ladies and gentlemen. You only win, or you only profit. Your net profit is only 35. If the ball land on any other number, right? If the ball land on number 30, you lose. Ball land on any other number except number 20, you will lose. And if you lose, you will lose $1. Okay. Again, the total slot here is 38. That's why if it's land on any other 36 slot, you will lose $1. So you say, wow, that's based on this thing here from the eyesight, you say, wow, that is a very good art, right? $1 to win 35, 1 to 35, right? For every dollar I bet, I could win $35. That's very good art, right? But is it good, really good, right? It is really what it look like. So in order to do this item, and this is what the expected value come in is. The expected value come in is basically tell you in the long run, if you play in this game, if you go on to casino and you play on this roulette table, what do you expect to gain out of it? What is your expectation? I agree, if you play, right, casino, if you go casino, you expect to win. But really, will you win, right? That's what the expected item. So this is what I ask you to do is, again, we need the amount, we need the probability, and we need the multiplication of the amount times the probability. Those are the 3 items that I asked you guys, the first column, the second column, and third column. Okay, so actually you need, this column is just to identify what your gain and what your loss is. So in this case, do you agree that for this particular game, My gain value, my gain, because it's gain, I put in positive because I gain $35. Again, I win or profit $35. That's my gain. And my loss, I will lose $1, right? If the ball land on anything else, I will lose $1. So that's where my amount come in is what do I win, what do I gain, and what is my loss. My loss, I put in negative. My gain, I put in positive. The probability of winning, do you agree that I only have one number 20 out of the total of 38 number? Again, there are 36 number with the 0 and the double 0. So there are 38 slots, right? So there is only one slot that I can win, which is number 20 out of the total of 38 slot, which is, that's where my 1 out of the 38 come in. The probability of me winning, and in order for me to win, the ball got to land on number 20. So that's where my 1 over 38. And what is the probability of my loss? How do I lose? Well, to lose, well, if it's land on any other number except the 20, I will lose. Meaning, do you see that there's only one way that I can win, and there are 37 ways that I will lose, right? And again, if you connect this to the odd we have earlier, if you connect to the odd we have earlier, odd in favor of winning is 1 against 1 to 37, right? So again, clearly we are not in a good odd here. So in terms of this thing here, 1 over 38, the probability of you winning, because again, you have only one slot out of the total 38 slot. And the probability of you losing will be the 37 slot out of the 38 slot that you have, right? And again, you just divide them to give you this number. And now what is the third column? The third column is all you do is you take the first column, the 35, multiply to the second column, which is 35 multiplied to this item, 0.026311. And again, keep as much decimal as you can. You only round at the last stage. You only round as your final answer. And again, you take this first item, which is -1, multiplied to 0.9736842. And those, or this is the 2 items you have. So again, first of all, everybody see where my amount come from, which is the gain, my probability, and the third column is I just take this item and this item, I multiply them together. That's where my step 1 and step 2. And to finish this thing off, all I need to do is take whatever in the column, the third column, I add them together. But in this case, I have a negative number. So basically 0.9210495, subtract because of the negative, subtract 0.9736842. And if I subtract that, I get 0.0526. And again, the question that will ask you is route to the nearest cent. So in this item, because it's a negative result, we expect to lose 5 cents on a dollar. Meaning if you play this game in the long run, you should expect to lose 5 cents for every dollar you spend. Okay, so if you spend $1, you lose 5 cents. If you spend $100, you lose 50 cents. If you spend $1,000, you lose $5. So basically, the casino only take 5 cents on a dollar for each person, and then they still make money. And like if you look at this thing here, like I mentioned, the odd is 1 to 37, meaning there is one way you can win. There are 37 ways you will lose. So if you look at this thing here, the payout, if they pay $37, then this game is even out. Because they pay you only $35, you look at this thing here, and you see that we have, again, our odd is not matched with our profit. But that's what we have, and doesn't matter. Again, one thing is doesn't matter. Whoever played the roulette, I just take this game because some of you guys probably saw it. No matter where you bet on the roulette board, you can bet the first 12, the last 12, the middle 12, or red, black, or whatever. No matter where you bet, for $1 you bet on it, you expect to lose 5 cents. Okay, so that's what the item you have, or that's what the expected value. Okay, so again, I know this is the first question, is a little bit puzzling, Let's take a look at the second question, and then I will ask you if you have question after this one here. Let's take a look at this item here. Let's again, if you have question, hold your question. Hopefully the second one will be a little bit clear, and hopefully you guys see what to do once you have it's clear now. So looking at this item, let's say that this is what we have. This game is a little bit different, right? A game is playing using one dice. So we have one dice. If the dice is roll and show a number 5, the player will win $7. Okay, so you have this dice. I have this dice in my hand. I will roll this dice, and if it's land on number 5, I will pay you $7. If the dice land on any other number that is not 5, right? If it's land on anything that is not a number 5, you will not win anything. You won't win anything, right? But in order for you to play, you need to put in $1. What is the game expected value? So when they say you win $7 here, meaning what is your gain, right? So look at this thing here. When you see that they ask you for expected value, this is what you need, is you need to have the amount, what is your gain, and the probability of your gain, right? So what is the amount of you gain? You win $7, but you not really gain $7. Because in order for you to qualify, you need to pay me $1 to play. So your net profit, right? Your gain is you only gain $6. You're not gaining $7 because originally there is a $1 in your pocket, right? If you don't give me this $1, you cannot qualify to win anything. So you have to give me $1 first. So when I say you win, I give you $7. Originally, there is $1 that your investment. So your gain here is not you gain $7. Your gain here is only you gain $6. Okay. And again, what is your loss? Well, your loss, if it's land on number 6, you lose, and you only lose that $1, right? The fee, right? If it's land on number 2, you lost, and you lose that $1. Agree? So again, that's where a small confusion in terms that people say, oh, I win $7, but that's not your profit. That is not your gain, right? That's not your net profit. So you have to think in terms of how much increase from the original amount, right? If you pay $2 and you win 10, meaning you only gain $8. So in this case, you pay $1 and you win 7, your original gain only $6. So what is the probability? What is my dice? Do you agree that my dice have 6-sided? One side contain number 1, one side contain number 2, one side contain number 3, number 4, number 5, number 6, right? So in this case, this is what I have. So in this case, this is what I have, that I have one side contain number 5 out of the 6 side, that total dice that they have, okay? And do you agree that I have 5 other side that I can lose, right? If it's land on number 2, I lost. If it's land number 1, I lost. If it's land number 3, land on 4, or land on number 6, I will lose. So the probability of me losing this $1 is 5 out of 6. And the probability of me gain or winning is 1 out of 6, okay? So everybody see that this is the same dice we have prior to this thing here. We have one side contain number 5 out of total 6 side. That's where the 1 out of 6. And they are 5 out of 6 because if you exclude the number 5 out, you have only 5 side left. And if you multiply this thing in, you have 6 multiplied to 0.16, you will get 1, right? And if you multiply a -1 to this item here, you get -0.83333. And in this case, if you take 1 minus 0.83333, you will get 0.16666, meaning again, we all expect, because it's a positive number, because it's a positive number, we all expect to win 17 cents on a dollar for this game. Okay, if it's negative like the previous one, we expect to lose. This one here, we expect to win. So if you expect to win, this is a good this is a good game for you, meaning in the long run, you will profit. In the long run, this game, the house will lose. And that's why casino don't play this game, right? The casino don't play this game because in the long run, the casino will lose 15 cents on 17 cents on every dollar. So why would they open the casino and expect to lose to you guys, right? And that's why you don't see this game, you know. But again, let me pause right here and let me ask you guys, in terms of the question of how do we determine the amount, how do you find the probability, and how I get the third column by or the fourth column in this case by multiply the two. Question here, ladies and gentlemen. All right, let's try another one. Similar to that, the expected value, right? They ask you for this one here, they ask you what is Melinda expectation, the expected value, or if Melinda buy 2 tickets in the rifle, what will be her expected value or expectation? So looking at this thing here, what is the setup, this raffle ticket? If you go to church, if you go to the fair, if you go to anything, they ask you to buy this, you know, fundraiser, we have this raffle ticket. So this is what Melinda have, right? This is the story. Melinda buy 1 raffle ticket at her church with the following prices. So they say, oh, we have this raffle ticket. There will be 1 prize winning $1,000. 1 prize winning $500. There will be 5 prize winning $100, right? And before we can draw the ticket, before we can draw a winner, we need to sold 1,000 tickets, right? There are a total of 1,000 tickets sold at $3 a piece. So if you look at this thing here, you say, oh, that's a good investment. I only need to pay $3, but I could win, right? If I buy 1 ticket, I could win 1,000, or I could win 500, or I could win 100, right? If I buy 1 ticket, those are my chances. I can win either 1,000, either 500, or either 100. And you say, well, that's not bad, right? So what is Melinda expectation? What is Melinda expected value? So looking at this thing here, do you agree that we have the price, right? So looking at this thing here, again, I guess I need to fix that we need 4 columns instead of 3. You need the amount, we need the probability. Those are the 2 main columns. So do you agree that the price is this? The price is you either win 1,000, which is you have 1 prize. You either win 500, which is 1 prize, or you can win 100, but there are 5 different 100, which is 5 of them. And if you happen to be an unlucky one, you will lose, and you only lose $3. You say, oh, $3, but I can win that much, right? So what is the actual amount, right? The price, those are your price. Those are the price, but what is the amount? Do you agree that your gain, you have to take that 1,000 and minus your original investment, which is your original investment is $3. So you need to take this 1,000 minus the 3. So do you agree that even if you win this price of 1,000, but your net profit or your gain is only $997? Same thing go, right? If you win, if you are lucky and you win second prize of this 500, your net profit is only $497 because we have to subtract, we need to subtract the $3 of my original dollar, right? If I don't play this game, I got $3 in my pocket, ladies and gentlemen. If I play this game and I win second prize, I have $500 in my pocket, but originally my $3 is my $3, right? The judge didn't give me the extra $3. So that's why the gain here, you have to subtract from your from your investment, right? So the loss very easy. Hopefully you see the loss is the same. The loss is you only lose $3, right? But the gain is the most important thing. Is you need to ask yourself is what is the gain? In this case, the gain, you have to deduct your investment of $3. First of all, question with how I came up with this amount. The price is not the amount of winning, or not the amount of gaining, or not the amount of loss. And that's why I mentioned that you need to know your amount of gain and the amount of loss. Now, let's take a look at the probability of winning this 1,000 in price, but gain only 997, right? So if what is the probability of you winning this price of $1,000? Well, do you agree that there's only one ticket can win? One ticket can win the first prize, which is 1 out of 1,000. And there's only one ticket can win the 500. And there are 5 tickets can win the 100 in terms of the consolation prize, right? And if you add this, you have 1 ticket of winning the first prize, 1 ticket of winning the second prize, and 5 tickets of winning the consolation of $100 in prize. Do you agree that there are a total of 7 winners and there are 993 losers here, right? Because there's only 7 can win. There's only 7 of them can win this first prize, the 1,000, the 500, and the 100. But there are 1,000 people in total. There are 1,000 tickets, meaning the probability of losing is 993. Because 1,000 minus 7 winner, we will have 993, should say, people who donated, right? So again, if you look at this thing here, 1 plus 1 plus 5 plus 993, that have to be equal to 1,000 people that we have in terms of the 1,000 people we have in terms of the total ticket that we sold. Okay, so that's the primary, or that's the hardest item, is to find the amount and to find the probability. If you can find the amount and find the probability, all you need to do is multiply them together. 999 multiplied to 1 over 1,000, 499 multiplied to 1 over 1,000, 99 multiplied to 5 over 1,000, and -3 multiplied to 993, sorry, not 997, ladies and gentlemen. This is 993, should be 993, not 997. So did my answer came out wrong? So this right here should be 993, not 997. Okay. So again, if you take what is -3? -3 multiplied to 993 divided by 1,000. So the number is correct. The answer is correct, -2.979. It's just that the number up here that I have is incorrect. So I did the correct answer, but I did not put in the right here. Then it's 993, not 997. Okay. So once you have that, this is all you need to do is multiply them, and then you just add them together. 0.997 plus 0.497 plus 0.485 plus, because of a negative, you have that negative. So looking at this thing here, if you add them all together, you will see that we have a -1. What does it mean? -1? -1 meaning Melinda should expect to lose $1 for every $3 she spent. Okay, meaning the church take in $1 from each person to do this fundraiser. Okay, and if you take a look at this thing here, right? If you take a look at this item, there is 1,000 plus the 500 plus 5 of the 100 do you agree that if you add them, again, why do I have 500, 500? Because 5 of the 100 equal to 500. Do you see that the church took in 3,000? Each ticket is $3, 1,000 ticket, that's 3,000. But the church give it back 2,000, meaning again, that's what they happen, or this is what the result is, right? We do the fundraiser, the raffle ticket is for fundraiser. So the church take in $1 on a ticket, right? Each ticket, each $3 ticket, the church take in $1. They return the $2 for the pool, the prize pool, right? So again, that's what we have here in terms of, because of the negative, Melinda should expect to lose $1. Okay. Again, I know you say, wait, I played this raffle ticket. Melinda played this raffle ticket. She expect to win 1,000. Yes, that's our expectation. But the true value behind the game, the true expected value behind the game is you will lose $1. Because as you can see, there are 993 loser. There's only 7 winner. There are 993 loser here. Okay. Donator. And again, if you buy 2 tickets, again, for 1 ticket, you expect to lose $1. If you buy 2 tickets, you expect to lose $2. If you buy 3 tickets, you expect to lose $3. If you buy the whole 1,000 ticket, you can see you expect to lose $1,000. Okay, so that's what Bob B, they say if Melinda buy 2 tickets for this raffle, what is her expected value? Well, her expected value is basically multiplied to how many tickets she have. So if 1 ticket is -1, well, if she buy 5 tickets, that would be -5, which is -$5. You expect to lose $5. Okay. So again, question here, ladies and gentlemen, question of the expected value, how to set up and how to answer, how to interpret the answer. Right. If you don't have question, let's take a look at 10.7. So 10.7, this is your additional rule. And the problem with the additional rule that you will see, the main thing about the additional rule for probability is you have to identify the mutually exclusive event versus not mutually exclusive event. So how can you determine if the event is mutually exclusive? Well, if the 2 events that we're looking for cannot occur at the same exact time, then the 2 events will be mutually exclusive. Okay, so as you will see right here, you will see that they will ask you to find the probability of something or something. So to find the probability of something or something, this is what you need to do is, if they are mutually exclusive, all you need to do is find the probability of the first item plus the probability of the second item, we're done. We're good to go. If they are not mutually exclusive, and again, not mutually exclusive is when they do have something in common. And this is the problem, ladies and gentlemen. If you have nothing in common, you are mutually exclusive. If you do have something in common, then you are not mutually exclusive. Okay. And if you are not mutually exclusive, you have to subtract the common item. We will get to this formula a little bit. Basically, they tell you find the first item plus the second item minus what they have in common. Okay, so let's take a look at the problem here. Let's take a look at, let's focus on the mutually exclusive item. So this is what they ask you is, you rolling a single 6-sided dice. So again, I have that 6-sided dice over there, right? You roll this item here. Find the probability of you roll a number 3 or a number 5. So do you agree that this dice, I do not have a single side that contain both a number 5 and also a number 3? because as you can see, my dice, right? My dice is either contain number 3 or contain number 5. I don't not like, there's no way that number 3 and number 5 land at the same time, right? So as you can see, this item here, they are mutually exclusive. And if they are mutually exclusive, all you need to do is we need to find the probability of a 3 plus the probability of a 5. What is the probability of me rolling dice and this dice land on number 3? Do you agree that there are one side out of the total 6 sides? So in this case, there are one side contain number 3, there are one side contain number 5, and that's where I have 1/6 plus 1/6. And that's why I have 2/6, because add them, I just add the top and kept the bottom. Divide them or reduce this, I get 1/3, and again 0.3333. And this is the probability of me roll the dice and the dice land on either number 5 or number 3. Okay, because they are mutually exclusive. The number 3 and the number 5 cannot occur at the same time if I only roll one dice. If I roll 2 dice, then yes, right, there's a number 3 and there's number 5, but we deal with that later. This one here, we only deal with one dice. Okay, so same thing go, right? Same thing go. Looking at this thing here, you roll a single dice, right? A single 6-sided dice. Find the probability of you roll a number 1 or a number greater than 4. So looking at this thing here, can these two criteria happen at the same time? Can I roll the dice and the dice land on number 1? Or if it's not land on number 1, can it land on number greater than 4? Remember, what is the number greater than 4? Well, the number greater than 4 is the number 5 and number 6. Right? Which is, looking at this thing here, there's no way, it's impossible for you to roll this dice and number 1 come out and also number 5 or number 6 come out at the same time, because you have only one dice, right? So you can see that this item, they are mutually exclusive because the two criteria cannot happen at the same time. And again, what is the probability of me land on number 1? Well, I have one number 1 out of 6. What is the probability of me land on the number that is bigger than 4? Well, there are 2. Number 5 is bigger than 4. Number 6 is bigger than 4. So there are 2 out of 6. And if I add them together, I have 3/6. And that's why I have 50%, right? 50-50, I roll this dice, is either land on number 1 or land on a number bigger than 4. Okay, so first of all, question here in terms of a mutually exclusive event. And that's what the addition rule tell you, that if you identify that they are mutually exclusive, meaning they have nothing in common, then all you need to do is take the, find the first one, find the second one, and add them together. Same thing go. A restaurant have a 3-piece of apple pie, 5 pieces of cherry pie, and 4 pieces of pumpkin pie in its dessert case. If a customer select at random 1 pie for dessert, find the probability that that customer select either a cherry pie or a pumpkin pie, right? So looking at this thing here, do you agree that we do not have any pie that include the cherry together with a pumpkin pie, right? You either have an apple pie, a cherry pie, or a pumpkin pie, right? We don't have any pie that have half of a cherry and half a pumpkin together. They did not tell us for this particular problem, right? So looking at this thing here, do you agree that if you go into this case, and let's say that they turn off the light, right? They have this item in the refrigerator, you go in, there's no light, it's so dark, you randomly select one dessert. What is the probability of you select this dessert, and this dessert is a cherry pie or a pumpkin pie, right? So do you agree that if you select one item, there is no way that you select one item and the cherry and also a pumpkin pie appear at the same time, right? They cannot come out at the same time. They cannot occur at the same time. And that's why this question, the word or, is mutually exclusive, right? So looking at this thing here, the probability of a cherry pie or a pumpkin pie is basically you find the probability of the cherry pie plus the probability of a pumpkin pie, and you add them together. What is the probability of cherry pie? How many cherry do I have? Do you agree that there are 5 cherry out of 12? Again, what is the total pie in this refrigerator, or in this case? There are 12 total, 3, 5, and 4. There are a total of 12 pie, right? There are 12 pieces of pie left. And again, what is the probability of pumpkin pie, which is we have 4 out of 12. If you add them together, you have 9 out of 12. 9 out of 12 will give you 0.75. So in this case, because they do not have anything, do not have anything in common, that's why they are mutually exclusive. And if they are mutually exclusive, you just need to add them up, find the probability of the first one plus the probability of the second one. You add them up and you either reduce them or give the decimal form. Question with C, ladies and gentlemen. Now, let's take a look at the not mutually exclusive event. So how can the problem be not mutually exclusive event? Let's go with the dice one more time, right? You are rolling a single 6-sided dice. You still rolling a single 6-sided dice. Find the probability of rolling a 2 or a number less than 4. So looking at this thing here, this item is not mutually exclusive. Why is not mutually exclusive? Because a number 2 itself is less than 4. Because there is something, when you roll this thing here, the 2 criteria that you're looking for, ladies and gentlemen, the 2 criteria you're looking for can appear at the same time. What are the criteria? The criteria is you either get a number 2. If it's not number 2, you will get a number less than 4. Those are the 2 criteria, the number 2 or a number less than 4. And because there is a number 2 who is also less than number 4, meaning they do have something in common. And if they do have something in common, ladies and gentlemen, that is not mutually exclusive. Okay? If they share something, if the criteria share some object, they are not mutually exclusive event. And if they are not mutually exclusive event, you need to find the probability of the first one plus the probability of the second one minus what they share. So in this case, this is what we have is the probability of number 2 or a number less than 4. Do you agree that the probability of number 2 is we have one number 2 out of the 6 sides of dice? The probability of number less than 4, there are 3 because number 3, number 2, and number 1 over 6. And the probability of a number 2 and that is less than 4, there are one number 2 that is less than 4 out of 6. You add them up. 1 plus 3 is 4. 4 minus 1 is, you get 3. 3 over this will give you 0.5. Okay, so the difference between this problem versus the other one, if you remember the other one, they ask you find the probability of number 1 or the number greater than 4, right? Last time we have the number bigger than 4, which the number bigger than 4 does not intersect with the number 1 because 1 is not bigger than 4. This one here, the difference is they ask you for the number less than 4, and there is an intersection. There are some common item. Okay, so the next one here, I explain a little bit different, not different, but hopefully the next example you will see the idea here. So let's say a single card draw from a standard deck of cards, and if you don't know the standard decks of cards. This is the standard decks of cards. We have 52 cards from ace to king, and they are divided into 4 different suited, right? We have a club, a spade, the heart, and the diamond. So again, this is your standard decks of cards. So this is what they ask you is find the probability of a king or a heart or a red card. So everybody see that this is what they ask you is they ask you, we need to find the probability of a king. This is my king, which is a K. This is what I asked me to do is go in here. If I shuffle all this thing around, and I ask you to find me the probability of a king or the red card. So everybody see that my red card is this item here, right? So probability of a king or a red card, that's what they asked me. And if you look at this item, right? If you look at this item, meaning none of this thing here matter because those are not the king and those are not red. So this is just the group of item I'm looking at is I'm looking at the king, and as long as the is even if it's black king, it fit the description of a king, right? Or a red card, right? So looking at this thing here, do you see that there are something in common? There are something fit the description of a king, and it is also a red card. There is some king who also fit the description of red. So because they do share something, because they do have something in common, as you can see, they have the intersection of the king, which are red, which is 2 of them, right? So in this case, because they fit the description, there are some items fit both description, they are not mutually exclusive. And if they are not mutually exclusive, we need to find the first item, probability of A plus probability of B minus the intersection of the 2. So what is the probability of a king? Do you agree the probability of a king? We have 4 king out of, there are 4 king, right? This is the king. This is the king, this is the king, this is the king, this is the king. So there are 4 king out of the total of 52 cards, right? And again, how many red cards are there? If you add all of the red cards, there are 26 red cards out of 52. And how many red cards who is a king, or how many king who are red, which is 2 out of 52. If you add them up, you have 28. Again, 4 plus 26 to give you 30. 30 minus 2 will give you 28. 28 over 52, you can reduce it by 4, which is 7 over 13, or you can give them a decimal. And again, you probably say, why is this problem? Why do I need to subtract them, right? Why can't it be like the other one? Just take the first item plus the second item and call it a day, right? Why do we need to subtract them? Well, think about this, ladies and gentlemen. This is the idea, or this is what we ask you is, do you agree that I asked you how many king, and you say, well, there are 4 of them, Mr. Tran, there are 4 king out of the total 52 cards. And when I ask you how many red cards, you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I ask you how many red cards, you tell me there are 26 red cards. Everybody see it right here. We count, everybody see that we count the king twice. We count, when I ask you how many king, you count it 1 time. When I ask you how many red cards, you count the king 1 more time, meaning you count this king twice. You double count them, ladies and gentlemen. And the reason why you need to subtract them, because you double count them, that's why you need to subtract them, because eventually or technically they only have one item, right? If you add this check, you have 26 check plus 2 more. That's where the 28 come from, right? What fit the description? King or red card. There are 28 of them in total. But if you base on the formula, the reason why the formula work is because we double count the king. And that's why the formula is solved in the sense that because they are intersection, we need to subtract them out because we double count the 2 red king twice. We double count them. That's why you subtract one of them out. Okay. Let me question with this one here before we take the next problem. Question with this item here. And let's do one more example here. Let's take a look at this item. So this not definition, but this problem, this is what I present to you is suppose the above data is from one of my last semester Math 203 test result. If I select one person, find the probability of the following, right? Find the probability of the person is a male student. So looking at this item here, what is the probability of a male student? So one thing I want to, the reason I give you this thing here is, do you see the word all? This one here, they don't find the probability of male student or something. They just ask you to find the probability of a male student. So to find the probability of a male student, everybody see that all we need to do is ask ourselves, how many male students, what is the total male student over the total number of students, right? So again, in terms of this thing here, find the probability of male student. The total male student is 16 over 34, which 16 divided by 34, you get 0.4706. If they ask you for decimal, or you can reduce them. I think I did Alex, and Alex, even if you don't reduce them, I think Alex still count, give you the point. So if you give them 16 over 34, I think they still give you credit. So again, looking at this thing here, because they don't have the word or, you can see that they just ask you for a simple probability. And if it's a simple probability, we just ask ourselves, what are we looking for? We're looking for the male student over the total. Similarly, for B, they ask you find the probability of a person is a C student. So again, looking at this thing here, this is my C student. My C student is here. So what is the probability of the C student? Well, how many C students do I have? In this case, my C student is 10. I have 10 C students out of the total of 34. As you can see, this is just a simple probability. So a simple probability, what we're looking for the C student, 10 of them out of the 34 total. And lastly, for this item here, one thing I want to point out to you guys is tomorrow on Thursday, you will see the word and again, but this item, find a proper person is a male and a C student, meaning looking at this thing here, how many students who is a male and also a C student. So it's not just the male by themselves, it's not just a C student by themselves. Do you agree that there are 7 of them who is a male student and also a C student, right? So in this case, there are 7 fit the description of a C and is a male student, which is 7 over 34, and you divide this 7 over 34, you will get 0.205883, similar 0.2059. Okay, so this thing here, this first 3 problem is just a simple probability, and the simple probability is basically tell you find a description, put that description over the total, right? You go in here, the probability of pick a male student is 16 out of 34. The C student 10 out of 34, a C student who is also a male is 7 out of 34. Now, here come the word that you will see, or as you will later on recognize a lot is you see this word or. Find the probability of a person is a D or an F student. So how do I find a D or an F student here? Well, do you agree that this is my D and this is my F student? So in terms of this thing here, do you agree? This is what I want to, or the purpose of this problem is, do you see that the blue line and the black line, the green line, the green box and the blue box, they do not intersect. They do not cross each other, right? And if they do not cross each other, everybody see that this is a mutually exclusive event because there is no such student who have a D and also a F criteria, right? Your test, you can either get a D or a F. You cannot get a D and a F, right? We don't have a score system that have a D and a F together. If you take two tests, you might have two grades, but only one test, you either have a D or a F on one particular test. So that's why the two boxes, they do not intersect. And if they do not intersect, you can see that they are mutually exclusive. And if they're mutually exclusive, life is good. Why? If they are mutually exclusive, all you need to do is add them together and divide by the total. 4 D student out of 34 plus 5 F student out of 34. And if you add them up, you have 9 out of 34. And that's what you have. Okay. And now, if I change it around, and again, I don't think you guys have question with mutually exclusive event. You probably have the question of the definition more than the solution itself. Find the property of the person is a male or same thing go, right? A male or a B student. So if you look at this thing here, this is my male, this is my male criteria, and this is my B student criteria. Do you agree? Do you agree that we do have something in common? We do have, to be exact, 2 students who is a male and also a B student. So because the two line, the blue line or the blue box and the green box, as you can see, they intersect each other. The blue box and the green box, they intersect each other. Because they intersect each other, they are not mutually exclusive event. And if they are not mutually exclusive event, you can see that this is what you need to do is you need to find the property of the male plus the property of the B student minus the property of a male who is also a B student. Okay, so again, 16 male over 34 plus the 8 over 34 minus the 2, because we double count them, right? We ask you how many male, you count me 16, you include that 2. And I ask you how many B, you tell me there's 8, you count that 2 one more time. We double count the 2, so we have to subtract one of them out, because that make it 4. We only have 2 students in the survey or in this problem. Okay, and let's do this last item that we have. And as you can see, this last item, the reason I give you this F is to show you that if you look at this item here, we can see again the word or is the item that you will see. Find the probability a person is a male or a C student. So to look at this thing here is basically the same as question A, question B with question C. So do you agree that we have a male student here and a C student here? So if you were to draw this, you can see that there is an intersection of some sort. There's an intersection. The two lines, they cross here. So to do this thing here, we see that they are crossing each other, meaning they are not mutually exclusive. And if they are not mutually exclusive, this is what you need to do is we need to find the property of a male. However, I see that we did the property of male right here. The property of male is this item we did right here. Property of male plus property of a C student. This is a C student, guys. Is that I changed it and I forgot to change this. This is the property of a C student, which is 10 out of this, minus the male and also a C student, which is you need to minus this item here. So again, if you look at this thing here, that's what we have in the sense that we take the 3 port that we do A, B, and C, we put it together in terms of this item here. 16 out of 34 plus 10 out of 34 minus 7 out of 34. You add them up and you divide, or in terms of you add them up and you subtract. If you take 0.4706 plus 0.2941 minus 0.0459, you should get something close to this. You should get something in terms of 0.6176. Okay. So again, the reason why I say close is because I round them up, so sometimes it's a little bit off. But looking at this item, question of how to determine if they are mutually exclusive or not mutually exclusive. And if you can determine if they're mutually exclusive or not mutually exclusive, hopefully you can identify your formula. Mutually exclusive is easy. If they are mutually exclusive, if you determine that they are mutually exclusive, you just find the property of the first item, the second item, you add them up, you are done. If they are not mutually exclusive, we are in trouble in the sense that we have to find the first item plus the second item minus what they have in common. Just because they have something common, we need to subtract them out. Okay. So question with this item here, ladies and gentlemen. I thought I can cover 10.8, but I'm running out of time, so we will stop here. We stop here today. This is 10.8 is the last item you have, which is the multiplication rule and the conditional probability. So we will work on more problem on next time. We will work on more